This is the lecture for section 7E on counting and probability. This section is all going to be about grouping and arranging items and determining how many ways that can happen. So the first one we're going to talk about here is arrangements with repetition. If we make our selections from a group of n choices, a total of n times n times n times n, or n to the r, different arrangements are possible. For example, how many 7-number license plates are possible? Well, you can see in this image here that we have 7 numbers, 1, 2, 3, 4, 5, 6, 7. We have the numbers 0 through 9, which are 10 distinct numbers. So you can see there's 10 choices for the first slot, 10 for the second, third, fourth, all the way through. So we can do 10 times 10 times 10, 7 times, which can be more simply written as 10 to the 7th power. And if we calculate that, there are 10 million different license plates just using numbers. How many different 7-character passwords can be formed with just the lowercase letters of the alphabet? Well, we have 7 letters, 1, 2, 3, 4, 5, 6, 7, or 7 spaces we have to fill in a letter. We are only using the lowercase options, of which there are 26 letters of the alphabet, which can be written in the lowercase form. So I've got 26 choices here, 26 here, 26 here for every single spot because of the fact that I could repeat any letter at any point in time. This is more simply written as 26 to the 7th power. The power means how many times you multiply the number by itself. And if I go to a calculator, that is going to give me 8,031,810,176. Again, this is just lowercase letters of the alphabet. When you create a password, you could use lower or upper or numbers or symbols. So clearly the number of passwords possible is a lot larger than just this value. The next type of problem is going to be what's called a permutation. When you work with a permutation, we have to have a few things here. All of our selections must come from a single group. So we know what the group is. We know how many items are in that group. No item may be selected more than once. The items are going to be distinct. And the order of the arrangement matters. So in a permutation, the order that you are put in matters. It matters if you are in first place versus 4th place. The way we can calculate permutations is with what is called the factorial symbol here. And if we are going to use all of the items that we have. There may be some cases where we don't, and we will see that formula a little bit later here. But for right now, we're going to use that. A middle school principal needs to schedule 6 different classes: algebra, English, history, Spanish, science, and gym in 6 different time periods. How many different class schedules would be possible? Well, we have 6 different subjects, and we must use all 6 of them. So the way that this works is in the first period slot, I've got 6 choices for a subject. Once that spot is taken, I then go to second period. There's only 5 left to choose from. When I get to the third period, there's 4, and then 3, and then 2, and then 1. That is what this exclamation symbol means. So in math, the exclamation stands for factorial. And what you do is you take the number that you start with and multiply by every single number going down by 1 until you hit 1. So for this, the principal could schedule the 6 classes in 720 different ways. Now, there are times though where you may have a group of items and we do not want to use all of them in my selection. Maybe I have 50 different pictures and I only have space to hang up 10 of them. So I'm going to have to pick which 10 I use and determine the order that I want to hang them on my wall. What I can use then is called the permutation formula, which is going to look like NPR. And it's this formula here. We're not going to talk about it a whole lot. I'm going to show you the technology form for it, but just so you can see. So N is the total number of items that we have. R is how many we are taking. So if I had, let's say, 10 items and I want to pick 5. So the way that I would do 10p5 on top is 10 factorial. On bottom, you're going to subtract those, 10 minus 5 factorial. So that gives me 10 factorial over 5 factorial. So then what happens, well, 10 factorial is 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. 5 factorial is 5, 4, 3, 2, 1. So what I need, because of canceling out, is only the first 5 numbers, 10, 9, 8, 7, 6. And that should make sense. Thinking about it a different way here, if I have 10 items and I can only arrange 5 of them, it means I have 5 spaces to fill. I have 10 choices for the first spot, and once that spot is taken, I now have 9 options for the second spot. Once 2 items have been selected, I now have 8 options for the third, 7 for the fourth, and 6 for the third. So the permutation formula can be used, or you can still think about it as like filling in the blanks like we did on the previous slide. On a team of 10 swimmers, how many possible 4-person relay teams are there? You can see they've drawn a little image here. If you have 10 swimmers to choose from, you have 10 choices for your first swimmer. You'll have 9 choices for your second swimmer, 8 for the third, and 7 for the fourth. So if you multiply 10 times 9 times 8 times 7, you're going to get 5,040 possible relay teams. That same answer could be found doing the formula 10p4. I'm going to use that same thing, 10 factorial over 10 minus 4 factorial. It's going to give me, run out of room here, 10, 9, 8, 7, 6, all the way down. So I'm going to stop at 6 for a reason, because the bottom, 10 minus 4, is 6 factorial. 6 factorial means 6, 5, 4, 3, 2, 1. So you'll see that those cancel. That's that 10, 9, 8, 7 that we have right there. If an international track event has 8 athletes participating and 3 medals, gold, silver, and bronze, are to be awarded, how many different orderings of the top 3 athletes are possible? So using the formula here on this one, I have 8 athletes. I want to arrange 3 of them. So 8p3. So I'm going to have 8 factorial over 8 minus 3 factorial. Well, 8 factorial is 8, 7, 6, and then times 5 factorial. The reason they stop at 5 is because 8 minus 3 is 5 factorial. So the 5 factorials cancel out. You're left with 8, 7, 6. Makes sense. I can have gold, silver, and bronze. Once my gold first place is determined, there are then 7 remaining for silver and then 6 remaining for bronze. Final answer is 336 different orderings of the top 3 athletes. One more here. A Little League manager has 15 children on her team. How many ways can she form a 9-player batting order? Well, we have 15 total children. We want to arrange 9 of them. So we're going to do 15 permute 9. And in this one, you're going to get 1,816,214,400. This is close to 2 billion batting orders just for 15 players. And I'll show you how to do that on Desmos here in just a second.
Let's say you want to do a permutation in Desmos. What you're going to do is type lowercase n, capital P, lowercase r, and you'll see that it goes from italics to regular font. So it's telling you it recognizes this function. You're going to open parentheses here, and you're going to put the n first, comma, second number, close parentheses. So for the one we just did, we had 15 and we wanted to arrange 9 of them. And unfortunately here, Desmos does not go that large. It's putting the number in scientific notation. And if you were to move that back, you are going to get the same answer that we had. The other way to do it is if you go to the keypad and go to the functions, it is down here at the very bottom, NPR. So if I click that, it's going to pull it up with the parentheses all ready to go. And let's say I have 10 items and I want to arrange 3 of them. That would be 720. So it is all available here on Desmos for you. Just make sure you go and use that. If you are unfamiliar with any other scientific calculator that has, most of them do have this function, but since everybody has access to this, this is the one that I'm going to show you guys.
The last type we're going to work on is a combination. In a combination, again, all selections are going to come from a group of items. No item can be selected more than once. Those items are all going to be distinct. But in this case, the order of there is no order here. There is no ordering, arranging, none of that. It doesn't matter. So all we have at this point is I want to group individuals together. So if I were to put you into groups for a project, it doesn't matter who I select first, second, and third. Your group is going to be the same. To do a combination, we'll have to use the formula. There is no way to write some blanks down and fill in the blanks and things like that. Combinations must be done with a formula. That formula here, again, I will show it to you, but we'll use the calculator, so don't worry about the formula. NCR, so we have so many items, N items. We want to choose so many of them, R of them. So N total, I want to choose R of them. I want to group R of them together. Still going to be N factorial, still going to be over N minus R factorial. But now we've divided by R factorial on the bottom. So this is read the number of combinations of N items taken R at a time. Let's look at an example. Suppose that you select 3 different flavors of ice cream in a shop that carries 12 flavors. So let's say you're putting it in a bowl. If you're putting 3 scoops in a bowl, it doesn't matter which scoop goes first. I'm going to have all 3 scoops in my bowl. I want to know how many flavor combinations are possible. Well, combinations, I'm going to use my combination here. I have 12. I want to choose 3 of them. So if I were to use the formula here, 12 factorial over 12 minus 3 factorial times 3 factorial. So simplifying 12 minus 3 is 9 factorial. So we'll first do on the top 12, 11, 10, 9 factorial, stopping there because 9 factorial is going to cancel out. So then we have 12, 11, and 10 on top, and then 3 factorial, or 3 times 2 times 1. So final result is going to be 220. Now, again, you're not going to have to do this by hand. I will show you how to do this in Desmos in just a second.
We can enter a combination the same way we enter a permutation here. So if I do lowercase n, capital C, lowercase r, open parentheses, I have 12. I want to choose 3 of them. You'll see that I get that 220 from that slide. I have 2 more examples here we're going to do. Says, how many 5-card hands can be dealt from a 48-card pinochle deck? Well, I have to just select a group of 5 cards. It doesn't matter the order I get my 5 cards. I just want 5 cards. So you can also go to the Functions tab and scroll down and select the NCR there. Up to you. The larger number is always going to go first. They're either the same number or the larger one is first. So 48, I want to choose 5 of them. So my answer here is 1,712,304 different 5-card decks from a pinochle deck. And the last question here, how many 6-player volleyball teams can be formed from 10 players? Well, again, I just need a group. I'm making a team. It doesn't matter order that I choose them. I just want 6 from my 10. So 10 goes first. I want to choose 6 of them. And there are 210 groups of 6 that I can make from 10. That is the end of your notes for this week. You will have your homework in Pearson for 7C and 7E. And then you also have your discussion board. So please make sure you do that.